recording here. So last week's topic was security, and in that security, there were highlights of how you can choose your password, what are the different techniques for authentication, and then two-way, three-way, and things like that. And also there was lots of links. I hope you clicked on those links and check the depth of information that is available out there for you. A lot of online applications and a lot of softwares allowing you to better manage your passwords and boost your the security of your uh, information and everything. So in the activity, actually, we have three main parts in the beginning. The first question is about passphrase manager. We know that these passphrase managers or softwares you can benefit. They basically look like a safe that you put all the key passwords and keywords in that. It actually generates those strong passwords for you, and you just need to memorize one master password. And by entering that master password, every website that you log in will be automatically completed using the software, and the software keeps that for you, so you don't need to remember. So as we said, the advantage is that you don't have to remember multiple passwords, and these passwords are strong typically because these are randomly generated long these are long randomly generated passwords, so there's um, it's less likely that there is a pattern in them, so that they can be stolen or hacked. And since they're being generated by the computer, basically they don't involve any personal sensitive information that you might otherwise use to make it easy to remember your password. But the disadvantage is that if somebody has that master key, well, it's a disaster, and they can access every single website that you had your password on, stored in this safe and this password manager software. The second one, some people wrote the same thing for passphrase generator. This is a different thing. Passphrase generator generators are typically websites or softwares that every time you ask for a passphrase from them, so they give you phrases that are easy to remember, uh, that are basically are not easy to remember and be hacked, but they don't keep them in the same place. So it's somehow the opposite of the first scenario, the passphrase manager that we talked about. They don't manage them for you, and you have to memorize a lot of passwords. But the advantage is that these passwords are strong, typically long, strong, cryptic passwords that are less likely to be hacked and to be used. One problem with these, though, can be they somehow, to make it more strong, to make the passwords more strong. Sometimes they add special characters to these passwords. So some websites might not accept those. So like exclamation mark, question mark, asterisk mark, or things like that. Like think about the special characters that some website might not accept as their passwords. In that case, that can be a problem. And the password that this generator gives you might not be usable for those specific password websites. Number three, using single sign on. This is where you want to sign up to a website, and they say, okay, would you like to use your Gmail or your Facebook or your LinkedIn credentials, so that you typically most of the time you say yes because it makes life more easier for you. You don't want to memorize every single password, which should be different if you want to be safe. In an ideal world, if we live in an ideal world, for every single website that you want to sign in, you should have a completely different username and password, which both are cryptic and difficult to be hacked, which is most of the time not possible. So these websites rely on the authentication of famous and popular websites and applications like Gmail or uh, it's typically Gmail or LinkedIn or Facebook. They rely on those. So if Facebook authenticates you, um, then basically they get that flag that this person was authenticated by me. So my website also authenticates this person because Facebook did it or Gmail did it. This way, by the way, they do not have access to your. So imagine I'm going to create an account on website X, and this website X is is asking for my um, Gmail credential. When I'm inputting my Gmail credential, this website doesn't have access to that. This is sent to Gmail that authenticates me and sends a flag. Hey, this guy's yeah, I authenticated this guy, so you can let him use your your website. But they might have access to your email um, to basically as a kind of linker to link you to the applications that they are um, they are offering. So the advantage is obvious. You don't have to have multiple different username and passwords for different websites. You just have one. But similar to the case that we discussed in number one, attackers can access everything, every single thing that you have used this SSO, single sign-on authentication, uh, to to access everything by just having, for instance, your Facebook credentials um, or your Gmail username and password. In general, we said that for highest level of security, two-factor or in extreme cases three-factor authentication is the best way. No password is safe, no matter how strong it is. Um, One interesting thing that I think I mentioned in the lecture was that with the emergence of quantum computers, these passwords, even hash that can take thousands of years to be hacked with typical supercomputers, can be cracked in seconds. So one of the dangers that people are these days talking about is that there will be no security, absolutely zero security with password username and password mechanism if quantum computers become popular. But two-factor and three-factor are the safest modes that we will see in quiz. Question 4 was up to you, so I read this and I graded, but this was up to you. The mechanisms that you use. Some of you answered in interesting ways. I like that. And what is the price of free? So in short, you pay for free with your personal information. That's typically this is what happens. This website is free, but you don't pay money, but you provide them with a lot of your personal information, which sometimes cannot be. My voice is not audible. Um Let me see. How about now? Did it get better? Hello, Dishdeep. Did it get better? All right. So I guess this is my mic. I changed it now. Should be good. If it wasn't good again, let me know. Yes. So this is in general what we discussed about, but still, I used to use some of these passphrase managers on my computer. It was successful. Uh, one problem with these softwares was it makes you really lazy. So you have hundreds of passwords stored there, and if for some reason this software stops working, you have a safe that you've lost the key to, and everything is in it. You don't have access to any of these websites. You haven't memorized those passwords, so it becomes a little bit difficult. um, so two-factor authentication these days are becoming more popular, as Seneca is also using. You have to have your phone with you. There is this Do app we're using. As soon as you enter your password, the second phase of authentication kicks in, and that's you have to say it's me on your phone. Banks are using these, so the two-factor authentication is getting much better. But this was an essay, so you had to write some words here. That's it for the activity. This is going to be uh, one before final activity. You have one more activity this week, which is related to the final project and is easy. You just need to think about how you're going to do your final project and the steps that we will discuss in today's lecture. Um, and that's it. There will be no more quiz. Last quiz was the final quiz of the semester. There's only one activity that you should complete by Sunday this week, and then for 3 weeks we will be working on the final project. 3 weeks, I mean the first, the second, and the third week of August will be only project. And this project is easy, by the way. It's easy. It's terribly easy, but you need to spend some time to do things as they're supposed to be done. That's the whole point of it. Any questions about this activity? Okay, so now let's see the quiz. Let me see if I have, yeah. Uh, I was I was doing this quiz 2 minutes ago. Well, not 2 minutes ago, about an hour ago. Uh, let me zoom in a little bit. I guess the zoom level is not good. No, not this much. Okay, so the question is, what are the factors in three-factor authentication? Three-factor authentication is authenticating. Okay, I guess you're good now, Dishdeep. Good. Uh, Three-factor authentication is first, authenticate my password. Second, authenticate using what I have, which is typically our phone. So you have an app on your phone, and you use that to confirm that this is you. Or sometimes you don't have an app, like Gmail uses typical text. It sends you text and you accept there. And number three works when you lose your password and you lose your phone, which is less likely to happen, but who knows? Hopefully, it will not happen to anybody. But if you lose your password and lose your phone, then there is this third factor that should be completed so that you can fully be authenticated. And that's with what you have. So your body. The third factor must be something related to your body, a unique thing related to your body. Your fingerprint, your retina are the two most popular authentication parts because they are unique and they're used. So the answer for this is you have to have password, you have to have a phone or a USB dongle, something like that, and then your fingerprint or retina. So this is what we said: what you know, what you have, and what you are, basically. Well, I wouldn't say what you are because you're not your body, but no. Anyways, let's say your body, a part of your body, fingerprint or retina. And what is the impact of cracked email account? Uh, that's typically these days we keep everything in our email. So stolen passwords and personal information, and because you are typically because many websites are relying on the security of your email. If somebody uh, cracks into your email, then they can change the password of sensitive parts that you have, and they can just say forget password, and because they have your email, an email will be sent to you. Since they have your email, they can easily change the password, lock you out basically, and they will be the owner, and they will have access to everything. So it's very dangerous actually these days. um, it's horrible. So now, for question number three, for security, network traffic should be encrypted. There are terms here uh, that are worth reviewing again. We know password protected. Well, network traffic cannot be password protected. Uh, Password protected. This is basically what happens is typically with wireless stuff. Uh, when I'm when you're using your phone, when you want to log in, the password characters that you enter for your Gmail, for instance, using your phone, are being distributed through these wireless waves in everywhere. And if somebody wants to really listen to that, these waves not only reach to the wireless router, but also can reach to a receiver that they have. And if these letters and characters are not encrypted, encrypted means they are uh, they are changed. They are encrypted using a key, right? A key that only you and the only your device, not you, only your device and the wireless router knows. uh, if they don't have if they don't know this key, they wouldn't be able to uh, get your information. They will just see gibberish. So a network must be encrypted. This settings that you this settings that you these settings that you use um, for different for different encryption when you're setting a wireless connection. This is all related to this. So never say no encryption. use at least some part of these encryption parts. Hash, we said, hash is a very interesting way of encryption. It results in a fixed number of is a fixed size phrase, no matter how long uh, your text or your password is. So let's say this will always result in, let's say, 20 characters, no matter if your password is 2 character or is 20 character. It always changes to a standard length, and this is a fundamental thing um, for blockchain. So in blockchain, the hashes are stored and authenticated. Anyways, we're not talking about those. Salt is a password that we said that when you're when you want to log into a website, your username and password must be stored in the database so that when you want to log in, what you enter can be compared to what the database has. But what if the database of that website gets cracked? What if somebody accesses to that database? Imagine tomorrow somebody steals database of Facebook, which happens from time to time for uh, not Facebook. I don't know if it happened to Facebook, but many websites they report, and sometimes they don't. You don't even know somebody has cracked their database. But to prevent that problem, because we can never avoid these cyber attacks, the way you store this information in the database should be hashed so that if somebody comes and steals your database, at least they cannot extract information from it. And we said that the most secure part is hashing a password that you enter. So you enter something that gets hashed. Uh, this website selects a random password that's called salt, and that random password also gets hashed, and the two hashes together are hashed again, and that hash is saved in the database. If somebody wants to crack this with the most powerful supercomputers that they have, it can take thousands of years to find the password and crack it. So interesting. For those of you who are interested in cybersecurity, it is very interesting. You need to be good at math, and it's a wonderful world, by the way. Question number 4. What is one problem with most password policies? The problem is that a, a, a it's not a weak password. A weak password can whatever the problem is, you have seen that first of all they're cumbersome. So sometimes if for 2 or 3 attempts the website doesn't accept the password that I'm trying to set based on the rules, I give up on that. It's cumbersome. You have to read all the rules. They say it must be not this character and not that character, but definitely this one. Use this one. Don't use that one. That one. Capital letters should be included. Numbers. Now you try 2, 3 times, and man, you give up on that. But apart from that, even if you try to find a password, there is always a chance that you create a weak password. We have seen this. Like you go back and check the slides of last week. No matter how many rules you have, first of all, you cannot go for more than a specific number of rules, because that will be even more cumbersome. But uh, still, there is a chance that you find a password that is easy to guess, but doesn't break any of those rules. So this is the problem with passwords. And Question 5. How is a user ID and password validated? This is what we just said. So first you perform one-way crypto hash of the entered password. You enter a password, that password gets hashed, and then a salt is automatically created, which is a random number, and that number gets hashed, and those hashes, the hash that is created from your password and the hash that is created from the salt get hashed again. So a phrase is generated. That phrase is compared to the computed uh, to the computed password, which is stored in the database, and if the two of them match, then you're authenticated. And question number 6: passwords on a server and a user ID database should not be stored in a plain text. Yes, hashtag. Yeah, they should not be stored in a plain text because we said that the database of the website might be hacked. So hash phrase, hash salt, hash the two, store in the database. Question 7: when creating a password, what is the most important thing? It's the strength and complexity of that password, right? Length is fine, but length is not solely length is not enough. The length can be uh, they can ask you for a like 24 character password, which is very typically should be very strong, but without any complexity you can put all of them one and you have 24 ones, easy peasy to guess. Lengths, solely lengths, is not enough. Secrecy, I know these are all good, but the thing that really describes what we want is the strength and complexity of that password. What are the factors in two-factor authentication? Yeah, password and phone. Basically, what I know and what I have. And question 9, if we want to match these, we first know what credential is. Credential is your identity. That identify the credentials identify you, what you have, what you are presenting. Then, if what you have, credentials, which is your identity, what you have, if that matches with what is stored on the database of a website, then the validation happens and acceptance happens. They accept you to log in to their service, and that's called authentication. Authorization then comes after that. After they authenticate you, after they see your, like, imagine you're entering a building, after they see your ID, they say, okay, now, yeah, you're the correct person. After that comes the authorization. They give you access to some parts of their building or some parts of their website, or if it is in a hotel, or a hotel, not hotel is not a bank. You go to the bank, they see your ID. Now they after they authenticate you, they give you authorization to access some services that you're using in their bank. Question number 10. Oh, we had a lot of questions in this quiz. What are two most common methods of cracking passwords? This is social engineering. We said you're posting a lot of personal information these days in social networks, and they can be used to guess your passwords. And compromised accounts, which is you use one weak password for multiple websites, and if one of them leaks, then they have access to everything else. Others are also some weaknesses, but they're not as popular as BNC. And what characters begin a URL to indicate an encrypted internet connection? This is HTTPS. What is the difference between HTTP and HTTPS? Does somebody know? Can you explain? What is special about HTTPS?
HTTPS is secured.
Yes, Sanjana, it is secured, but how is it secured?
Um,
What's so special about it that is secured?
it's probably authenticated.
Um, well, actually, thank you. Well, actually, it is. It is. It is the same way that you do encryption in your wireless. As we said, when you're encrypting the data, your data uh, is is changing. It's becoming encrypted. So that encrypted code is being sent, and it requires decoding. For the HTTPS domains, it's also like that. So whatever you're entering on your end becomes encrypted, and it goes to the servers of that domain, and using the shared key that only uh, basically they know and your browser knows. Based on that key, the data gets decrypted. The the advantage, what's the advantage? Any node in between that node, there are several nodes. When I'm connecting to my Gmail, there are several nodes in between, and my information has to pass through these nodes. If anybody is sitting there listening to this, or spying on that, they will not understand. They will receive the data, but the data is encrypted. It's not just plain text. But in HTTP, it's just plain text. Anybody that wants to access, if it is in between these nodes and can access this, your data will leak. But in HTTPS, the data will be kept encrypted until it reaches to the servers of the destination, and there your message, your information will become decrypted, um, and the rest of the thing. Okay, wonderful last quiz. I hope you have learned some basics of, in general, ICT. We've talked about so many things this semester, and I hope this can give you a better idea, a better understanding of what's going on, and what is that you're more interested in. Okay, any questions about this quiz? All right. If there is no question, I'll leave this.
Um,
Oh, sorry, I closed it. But yeah, go ahead, Sanjana.
Actually, no, I do not have questions about quiz. But I want to ask if we want to ask something or we have any queries, not during the class. When are the office hours when
Yeah,
we
we
can
can.
connect to you?
You can always send me. You can always send a text in Teams to me, and just text me. And as soon as I see that, I will reply. There's no
Okay,
there's no specific time. You can ask whatever you want anytime. Just text me on Teams.
okay. Thank you,
Yeah,
Professor.
yeah, no problem. Uh, okay, that's that. Well, that takes us to our lecture today. We will learn something in lecture, and after lecture, I will Uh, I don't think you're tired yet, so let's not have a break. But after the lecture, you will have a 5 minute break, and I want everybody come back after that because we will be talking about our final project. And those who are not here will probably mm, terribly miss that part unless they watch it later. Uh, so today's lecture is about project management. And this project management is what will be targeted in the final project. Sorry, let me check if I'm recording. Yeah. Um, the final project that will be distributed today is is a mixture of project management that today you will hear about it, and some coding, some C coding. But it's not really coding because the snapshot of those codes will be given to you, and you just need to uh, understand the code, comment the code, and understand how it works, and write the code in Visual Studio and run. But this is a group project, and there will be a one project manager in that group, one lead in that group that you should decide, and you should let me know who the project manager is. So listen to this because any one of you can be that project manager. We want you to be aligned with the headlines of project management, and mm, uh, later later use your skills and boost your skills for any management later, because project management is a well paid job. Now, if you're a project manager someday somewhere, you're good to go for the rest of your life. Okay, today we will be discussing this project management, what it is, some typical IT projects that failed actually. Uh, what does a project manager do? Project management process groups, um, different stages, different things in the loop that should be done. Advantages of project management and project management certification. You have one last activity, people. You have one last activity which is very related to what you will be doing. Um, and this is about these steps. It's about four. It asks you to write about each of these stages in your activity, considering your final project. So this is basically a very good start, a very good kickstart for your final project. By final project, it's not a difficult project like compared to what you will be doing next year in, for instance, in OP244. It's just a tip of an iceberg. It's really a small thing, but it's where we start, and in that sense, it becomes valuable. Um, so in project management, we think about how to make things happen. You use all your skills to manage a team, to manage the three pillars of a project that we will see, so that that target, that thing happens with good quality, acceptable quality, and in a timely manner by meeting the deadlines. Uh, so this is all we will be talking about today. Uh, if you're a programmer, you just concentrate on one aspect of one module, let's say one or two or couple modules, or just a sub part of a big picture of the project. Uh, that is you as a programmer, but you know more details about you have a smaller piece of that project basically as a programmer, but you have a far more access and knowledge to the details of that small part compared to anyone else, including the project manager. But a project manager is the exact is on the exact opposite side. The project manager sees the big picture, sees all the parts, how they're connected, uh, but doesn't know much detail about each of them. So next time you work, and if your manager doesn't know all the details, well, they know to some extent, but if they don't know all the details, don't blame them and don't think they are not knowledgeable people, because it's not their it's not even the definition of a project manager to know all the details. If you're lucky and your manager knows everything and every single detail of your project, then that's amazing. Probably that manager someday started as a programmer, or uh, like has been in that organization for a long, long time, so knows everything. But this is typically not the case. Uh, so you use, as a project manager, you use your skills, knowledge, and tools and techniques and everything you know to see the big picture, uh, and in the big picture see all the details related to the big picture, not the details of each part. See them and try to define the stages, define deliverables, and define timelines, and define what is included in this project and what is not. Um,
Are
somebody is unmuted.
are they
Let's see. Sanjana?
yes, Professor. Are they more like responsible for executing it?
Yes. It is very noisy. Could you repeat your statement again?
Are they more like responsible for executing it?
Exactly. They're responsible for executing, well, actually executing and linking all the sub projects and then executing that. Yeah, that's true.
Okay.
That's true. Um, and then it comes to uh, some examples of some mega projects. One of them mm, failed badly, apparently. As I was reading, I didn't know this actually. I was reading the history, the story of how it failed. So the government of Canada apparently in 2009 starts a project so that uh, the payment of all government employees become unified and come from an automated system, so that they don't have to sit down and calculate the salaries and use hundreds of rules and things like that. So basically automating the HR system and payroll system and all that. Uh, it was an ambitious project, took millions of dollars, and as you can see, uh, 2011, 2016, 2017, between 2018 and 2018, I think this is just 2018. They spent $659 million, and overall, uh, almost $1 billion project, uh, and it failed because it didn't work. And they in 2018 they actually somehow stopped it, and as different companies like IBM, they had people from IBM and other companies, they evaluated the problems of this project, and none of them was related to programming. Every single module was fine, working fine. There was no bug. Every single thing was working properly. But the problem was overall connecting these modules, and the lack of um, lack of lack of good project management in this project, and it failed. So if a programmer fails, the cost might be in the range of, I don't know, some thousands of dollars. But if a project manager fails, the cost can be, again, in some cases, the range of billions of dollars, as you can see. So it's an important thing to know. If in the project management they say every decision is easy if you are not making that, and every job is easy if you're not doing that. So from the point of view of a project manager, one mistake could be um, underestimating the amount of work that it takes to build a module, because they are not doing that. And from the point of view of the uh, the programmer or the person that is working under that project manager, the decisions can be easy because they are not making them. So this is a mutual understanding between a project manager and a person that is working to implement some of those modules. They have to know this, and for a project manager to know, typically things take longer than what we expect, and that should be taken into account when they are planning the project and defining the timelines and stuff like that. Uh, well, there's this saying that the fix is to fall in love with the problem. So if you like the problem, then you will be good at solving that. If you don't like the problem, that's probably what you shouldn't even start in the first place. What are some typical ICT projects? This one is important to know. Only 25% of the for this is for budgeting actually. So when a project manager is considering a project, only 25%, typically it's a rough number, 25% of the budget goes to developing new stuff. 75% of the budget typically is spent on updating the old modules and maintaining the things that we have, defining new workflows and stuff like that. So 75% of the budget should be considered for maintaining and upgrading what we have, and then just 25% for the things that require to be implemented. And these three pillars of project management is cost. You have to estimate the cost. Consider that 25%, 75%, and so many other details. Schedule time. You have to, as a project manager, you have to be able to know how much a work takes to be completed. If you don't know anything, you have to ask your employee, and your employee might say something which may not be realistic, or which may be much more than, or maybe it's the first time your employee is doing that. So maybe he doesn't have any idea. This is the first time he wants to implement something. He doesn't know. So you as a project manager, you should really be good at knowing how much time each task takes, um, and you should be good with budgeting stuff. And then the scope sometimes people forget, but the scope of the project is also very important. A project manager should decide what exactly should be done in this project and what exactly should not be done. Sometimes during the project, this scope, well, the stakeholders or the one you're working for might come up with new ideas, and that can change the scope of the project. That is the responsibility of the project manager, to think broad enough in the first place to put the tasks in the project that should be done, and to specifically say what will be avoided and what is not in the scope of this project. There are many softwares that you put tasks in them, so that tasks shows the scope of the project and the deadline. They allow you to put a deadline for that task, who or how many people uh, will be doing that, and how much money it will take, how many hours does it take, what is the things that we should purchase, and all those stuff. These are the things that you as a project manager should be good at. uh, and as we said, project managers mm, are not aware of every single detail of each module necessarily. They have a bird view of the project, so they see that they see the big picture. So some aspect of the project they might be good at, because they might be common for, like, yesterday I was talking to a friend of mine. She's a she's a developer, backend developer at RBC. So what she said was very interesting to me. She said, I asked her, "Is your manager to from?" Well, actually, it was not her manager. It was her manager's manager. So two level above her. I asked her if she's like, what's her background? Was she a programmer? How? She said she was a client advisor, and she was working at a branch. She was basically a teller, and after 15 years now, she's a project manager of the IT part, because she really knows how things go, but she doesn't know about programming. I cannot go there talk about programming skills, but she really understands what I will code for, and that's why she's a good manager. So they know some aspect of the project very well, because that aspect might be the place they started in that organization, so they know it very well. But you don't project manager does not necessarily know every single detail about all the aspects of the project. uh, does this make sense? let's see if, let's see who's here and who's not. Does this make sense so far? Okay, good, very good. um then uh Now, when it comes to uh, project management, you need to define the project so that it's good, it's cheap, and is fastly done. And this is what happens. Uh, you wanna you wanna do it fast, it doesn't become cheap. You wanna do it cheap, it doesn't become good. You wanna do it cheap and good, it can't be fast. So sometimes it becomes a struggle, and most of the time not possible. You see, in the middle, when you want this, when all the fast and cheap and great overlap, you end up uh, in a zone that's impossible. This is an impossible utopia. It never happens. This is just too ideal to be real. So uh, every project is closer to some of these circles, depending on the requirements that the project manager receives, probably from the stakeholders of that project, or defines based on his or her own uh, expertise. So if you want to make it a great project, well, free is somewhere here too. So if you want to make it great and free, try again. There's no way you can do that. Or you want to make it great and cheap, this can take forever. So this is the problem with project management. So you have to always find an equilibrium, a point that covers a little bit of these and finally satisfies the stakeholders, because at the end of the day, that's what you want to do. Satisfy the stakeholder uh, in timely manner by meeting all the deadlines, uh, by not spending more than the budget that they are considering for this, and obviously with a good quality, because you want to satisfy them. I want to give them what they needed, what they defined, what they wanted. In the process of project management, it starts from initiation. Initiation is the phase that you will do uh, today, or like by the next week. Definitely, you will be doing, and that is you will start thinking about who should do what, and when and how. So the project managers of in this final project, the project managers will have an Excel sheet form we will give them, and by talking to other team members, they will fill in that form which part of the project, which module will be done by who, how, by then, and they should consider some time before the deadline so that they receive the files, and they can test them and stuff like that. So during this time, this after initiation, that who will do what, then it comes to planning and design. Now everybody will start thinking about how they are going to do this, and if there is any problem. Now, if you want to implement this module, now I don't know much about like that specific thing that I'm supposed to do. So you have to ask your manager. I need some more time. I need to learn this. I need to do this. So it takes time. So this whole circulates around communication and optimization. So keep doing this. After initiation, then you plan what you want to do, and you plan, you execute, and then you monitor what happens. You as a programmer do this, and the project manager in a higher level will do that with the project. Sometimes you have to replan things. Sometimes things don't go the way you like. It's the art of problem solving. Never everything goes what you planned for. There's always a problem. So that's why it's just a loop. So in this loop, you plan and design, you execute, you monitor and control, and go back, replan, and do it until you have an acceptable project in time within the budget. Then it is the time for closing that project. And closing a project is documenting that project, which is very, very, very important. Uh, Documenting a project is as important uh, as as other parts, implementing and controlling and finishing it. You might not believe this, but long time ago, I was working for a company, and we realized that some of the products that have better documents are selling much more than the ones that they don't have documents. So it was we were our products were all high quality industry level automating stuff, so robotics stuff like that. Some of those we knew were better than other products, but final assessment that they did after analyzing the data of the sales data of 2 or 3 years, they realized no matter how good your machine works, one thing that is very important is well documenting that, and that's an art. You should First of all, you should include all the details, but in a way that the can user can really read them and understand them and implement them. That's why these days a lot of these machines come with an app. So application is audio visual. You watch a video, you see that thing, how it works, how it doesn't work. It's much better than text. So this might be another good job opportunity for you programmers. How to document stuff uh, to make it user friendly. So UX involves, user experience involves in that thing. Um, and then you have to be able to implement it, to implement the app. Um Graphic design involves, the art of making a video involves, and so many good things. um, Probably one ultimate UX that these days is going around, and i I'm really into it, is the virtual reality. So uh, it's amazing. So this is the ultimate type of UX. So in documenting, imagine you're selling something, right? And the tutorial for that comes in the way of virtual reality. That person can really sit there and get trained for how to work with whatever they have. Um, these are the things that are a little bit futuristic, but yeah, they're happening. Smart objectives. Uh, so there is an Excel sheet for this final project, uh, for every stage or every version of the project. There are 4 versions for this project that you need to do and submit. And for each part, the project manager of that group is responsible for completing these parts. So in that template, you will specify what you did uh, as specific things that you did, what happened, the measurable things, what happened now. Okay, now I can uh, do this part, or I cannot do this part. It's measurable. We agreed on this. Obviously, it was realistic, and when you're going to do this. So there is an Excel sheet. The project manager will fill in as you are discussing the project in teams, and the project manager, at the end of the day, the project manager needs to submit this part. For the This is called Gantt chart, by the way. In Gantt charts, you typically define the tasks, the budget, who will do what. So you see, like here, who will do which of these parts. And this is a website. This is clickable. You can click on this, and if you want, you can use this for project management. You define the task and you put the timeline for that. So from here to here, during week 1 and week 2, I'm going to do this task, then this one, then this one, and who will do that. Everything is clear, very easy for project management. Yeah, later click on this on the slides, and this will take you to the website that has all these. What are the advantages of project management? Not only when project management fails, it fails big, uh, uh, but also this art of project management, um, if it becomes successful, then all these happen. So better control of financial thing, better control over everything, basically, um, in shorter time and in a better way, probably lower overall cost if you can oversee everything, as a project manager, improved productivity, and all the good things, higher worker morale, higher customer satisfaction, and all the good things can happen with a very good project manager. Seneca has a project management uh, 2 semester, 8 month degree. So if you're interested, go ahead and take a look. For today's activity, you will need this. This is basically today's activity. If you look at today's activity, so we said planning, executing, controlling, and closing. For and your project will be released, right? What is what each of you, after receiving these projects, what each of you think about the planning part, the executing part, controlling part, and closing part. Think about it. This is a small, very easy project to do, but the whole point of it is you actually start implementing some of these project management skills, and everybody will do this. So the do for that is, as usual, Sunday, by 11:59 p.m. Sunday 31st. This is the deadline as usual. Think about it, write about it, and submit it by Sunday. And next class, we will not have any presentation. This will be your version 1 project demo. Every group separately we will connect, and the group will show me what they have done. So this is also our last lecture in that sense. And the first and the second and the third week of August will be delivery of version 1, 2, 3, and 4 phases of the project. But this activity should be done by Sunday. Please go ahead and do this activity. For the so you have already been assigned to teams, groups. If you haven't, there is a problem with your number of activity submissions or number of quiz submissions, typically both. If you're not assigned to any group, if you haven't seen a group, uh, that means there is a problem. Please send me a text and I will tell you why and what can be done. Well, there's not much that can be done. I guess most of the people now are assigned to their groups. Um, and if you don't see that you're not, if you see that you're not assigned, please let me know if you want. If not, I'm telling you the reason is uh, too few or zero activity submission, or too few quiz or zero quiz attendance. For initiation, in the initiation phase that you will think, now we're talking about each of these separately. In the initiation, as we said, you just assign the things, you think about the totality of the project and who should do what, task delegation, things like that. In the planning part, now everybody, including the project manager, should think about what in detail and when should be done. You basically plan the project. How do you plan the project? You break it down. You think about the tasks that should be done, and when that should be done, and start thinking about what I need to do that, what skills, what softwares, what hardware do I need to do this part. Um, and if something goes wrong, probably you can think about things that can go wrong and think about the solution for those. So this is the overall planning thing, but that planning is not enough. uh, this is also the planning. In the planning part, you can use these Gantt charts, put the activity over there. We don't have Gantt chart for our final project because the deadlines are already known for everybody, already decided. So there is no Gantt chart. The tasks are also known, so you don't need a breakdown, but the fact that you should see who should do what, who's going to do what part, who will be the project manager, and if you get the task, you should start thinking about like how are you going to do. There may be some codes. In this case, there are codes. Codes will be given to you. If you don't know the code or that module, what that module is supposed to do, you have to go check, learn, and things like that. Planning also involves some budgeting for procurement for equipments that you want to purchase, or the services like person hour thingy, the salary or the hardware or software licenses, hardware devices or software licenses that you need to purchase. This also obviously doesn't need to be done for our final project. Executing, now when everything is crystal clear for everybody, then you start executing the project. Everybody starts implementing whatever they're assigned to, and before the deadline, long before the deadline, typically everything should be passed to the project manager so that the project manager can put those together and test, and if there is a bug or there is something, they can return that to the programmer so that the programmer can fix that. Um, this is basically the monitoring and controlling part. So we already talked about it. The project manager needs to control everything, every single thing, test it, and then if something is wrong, take it back to the programmer. And don't think that as you and I as programmers shouldn't test our shouldn't test our code. You are the one that knows how to test your code. You have the one that knows how your code can be broken. So you have to fix all those before sending to the project manager. And these are the tasks that are put in the modules. The modules are the tasks that this one is also known in our final project. You don't like the project manager doesn't need to define them, but just needs to delegate them. And the closing. The closing is an Excel sheet in our project, final project. Now we will see. Shortly, we will see that. And that is the documenting. That's basically the main task that every programmer does, because they will comment the program. As I said, the code is given. The PDF, in the form of PDF, the code is given for every single version of the project. I just need to understand and document that code, and then obviously uh, write it in Visual Studio and run it, give us the executable files as well. Uh, but in the closing part, in general, you are closing everything. You are saying what we are giving you, how that works, what are the limitations, how it can be upgraded. You deliver all the source codes, all the executables, and everything. So this part is called deliverables. In a project, they are called deliverables. What are the deliverables of the project? That means what are you going to give me at the end of the day? And that includes source code, executables, documentation, including what is it, how it works, how can be updated, and what are the limitations. Typically, these are things that project managers are responsible for. For if you're interested in degree programs for project management, which I would suggest enrolling after 1 or 2, maybe 3 years in industry, work in industry. You should definitely involve in one of these project management degrees uh, and become a project manager finally. And this shows, this is the, yeah, the final slide shows that uh, well, actually failure in the job of project management affects everybody, from stakeholders to employees to everybody, and that's not good. Um, if everybody else fails, I guess project manager should not fail. So that's how important this job is. Very good. We are at the end of our slides. Please let me know if you have any questions. Uh,
Uh, Sir,
Mudit, yeah.
Professor, actually, I'm in group four. I just need to know, like, where is the list of member displayed? Like, what are the name of the members in that group? How can I get that?
Okay, let's check it out. Teams. If I go to Teams, like group 4, do you see my? Do you see the group now? My page. Mudit, are you there?
Sorry.
Do you see this?
Yes, sir.
Yeah. Okay. So here, you come here. You click on. I guess you all can manage this. Do you have this button here, Manage Team? And when you click, it shows the members.
Oh, okay.
Do you have this part?
Yeah, yeah. Got it, sir.
Yeah, okay. So this is how you know who's in your team, and you should start communicating. The project will be posted today. So each group has 4 members, except for one group that has only 2 members. Uh, and we will discuss the project after this. Any other question?
No, sir.
Okay, great. Everyone, is there any question? Okay, let's have a 7-minute break. That will be now it's 1:03. I will see you all at 1:10, and we will discuss the project. Please come back because this project part is important and we need to discuss it. We'll see you in 7 minutes from now. Okay. 6 people are here. 7. Okay. So this is the first of all, where you will find the project. You will find this project uh, in the course documents on Learn on Blackboard. When the same place you use, you always found uh, your activities, right? Course documents. I'll post it there. Um, what is the project? The project is actually uh, implementing a code that is given to you. How is it given to you? It will be given to you project. Yeah, let me take it here. This will be the project that will be given to you. This is the overview that is this MS Word file that now we will review. This is the plan for the project manager that needs to fill in. These are the project modules. Project modules are, we have 4 modules, A, B, C, and D. If you go inside each module, you will see PDF files. For example, and these are what the modules are called: fundamentals module, manipulations module, tokenizing module, and conversions module. If you go in each of these, oh, sorry, I was not recording. So I have to repeat. This is the project folder that you will find under documents. The overview is what we will overview it right now. And this one is for the this assessment plan is for the project manager to fill in. Project modules, we have 4 modules: fundamentals, manipulations, tokenizing, and conversion. And inside each of these modules, you will find 5 different PDFs. All of them have 5 different PDFs. One is the name of that module, header file. So if you open this, you will see that I'm gonna wait for it to open. Did it open? Yeah. So if you go to the header file, you will see that this is the header files code. You need to implement this in Visual Studio. This is a C code. So I guess by this time you're already familiar with C code because of CPP. What is the course? Well, 144. That's C programming course. So the thing that you need to do with each of these codes is that you need to implement this header file in Visual Studio, write the code, and then comment. Why do I need to include this stdio library? Why do I need to include stdlib, and so on and so forth? So you need to comment, document this line by line, and for that there is another document how to comment this. You need to document this as you're implementing in Visual Studio. One of them, so header file is the same for all 3 versions. You see now we have version 1, version 2, version 3. The header file, when you want to add the header file in Visual Studio, the header file for all of them is common. There's no change in the header file. One of them is main. Main is for testing this program. As you see, this is also very short, and it's just for, well, initially it wasn't given, but I tried to give this to you as well because I thought somebody might not be able to write the main. So 2 of them are shared for every version, main and header. But from version 1 to version 3, the code evolves. So you see in version 1, for instance, if you open, there is 24 lines of code. You need to comment every single line of this code and say what each line is doing, what the whole program is doing. In number 2, it's the same thing, but it's been extended with more functionality. 37 lines of code we have for version 2, and version 3, one more. In each of these steps, one more functionality has been added to this code. So if you check this now, it is 55 lines of code. These are due every week. So this is due the first week of August. This is due the second week of August. This is due the third week of August. And you will come to the class and you will present explain these, what happens in each of these modules. We have 4 people in each group. Module A, B, and C are more difficult and more time consuming to implement than module module D. Module D is, let me write it, for the project manager. Module D is for the project manager. It has some uh, code, but the codes are short, very short codes. This also is required by so see, like 17 lines of code and easy. Like the concept is, everything is easy actually about this module. Whoever becomes the project manager will have less coding load because the codes are much easier than module A, B, and C, but will have some project management tasks, specifically completing this Excel sheet. Is this clear so far?
Yes, sir. Yes, sir. But I have a doubt.
Okay.
Like if one of the team member have done the like wrong comments, the marks of the whole group
Don't
member
worry.
will be dropped.
Yeah, we will reach to that. We will reach to that. Don't worry. I will explain what to do. What else? I will explain that, Mudit. Thank you. Actually, that's a very good
Okay, sir.
question and concern. We will reach to that. Other than that, is there any other question? Victor, you said no. What is not clear?
Yep. So can you hear my voice?
I can hear you very well. Go ahead, please.
So, right. The code that you showed to us, I'm not sure what we're going to do inside. Are we going to write the result or just writing the progress of each code one? Like what we have to do during those, like the
Okay.
fundamentals, manipulation, and the tokenizing.
Okay, this is okay. Good question. First of all, we don't specifically say what these codes are doing. So this is what you should figure out. The code is there. There's some piece of code somebody has written. Okay.
Right.
What you need to do is to understand what this code is doing, and on top of that, what each line of code is doing. So that's what you will add by comments. You will add what this is for, what this module is for, what this is for, what this
Just
is for, what this is for. And
is it? Mhm.
yeah, go ahead.
Oh, you can finish it first.
Yeah, so you will have to understand and document every single line of the code, and what the whole module is doing, what the whole code is doing. That's for you to understand and explain. Actually, that's the whole project.
Okay, so for example, the first week we're doing like the fundamentals 1.c for one of the members, and
Hmm.
is it when we're
Yeah.
doing like this file, are we gonna do like the comment same as line one, like fundamentals v1, and then we're writing some sort of comments that this is gonna happen on this line, this is gonna happen on the next line,
Yeah,
and etc.
I see. For the commenting, please, you have to go to this folder which will be shared. There is also a video how to. It shows you how to comment. If I can run it here.
So in this source file,
Come on.
The programming comments document does say.
Sorry, wait a second. I need to.
So in this source file, the programming comments document does say that at the top of every source file,
for some reason, I am not able to send this video to my second screen. Let me see. Open bed. Uzun TV. Ah.
So in this source file,
okay. I guess
the programming
I did
comments
it.
document does say that at the
Do you see this? Can you see this video, and can you hear it?
Yes, we
Yeah, so this is how you will comment, add comments to these codes, just like this.
right.
Watch the video. I think it's clear now, right?
Yeah, this is like a finished version of like the converting C, right?
Yeah. This is the finished version of the converting C to a C code that also has comments. And you can go ahead and also read this document. This is very well documented for how to explain how that module works and stuff like that. So it's all it gives you all the detail on how to comment and how to report everything. So I'm referring you to this how to comment the code folder that will be shared soon with you, as like all these will be shared with you as the full project.
Right. Thanks. Thank you, sir.
Yeah, sure. What else? Please ask if you have any doubt or question about this. Okay. And so for the next week you come, this is what you will do. And the week after that, it's the same thing you will do, but you will do for the extended part. Now, let me open fundamental 1, for instance, and fundamental 2. If we compare these two, if we just compare these two, look, this is version 1, this is version 2. Up to line 23, line 23 is repeated. And after that, the second functionality starts. So for the second week, you have done this part, you have already done this part, you will be doing this part and will document and comment and document the same way you did for the first part. And the same thing for part 3. The only part that is a bonus, this is for A plus students, is version is version 4, which is also due on the third week of August. In the overview, I have written all the deadlines. Everything is clear. We'll go over it. That is for exception handling. What is exception handling? Exception handling is basically dealing with the unwanted information that user might input. For instance, you want them to input an array of integers, but they by mistake come, press enter and go. Should your program, typically if you don't take care of that, this is an exception. Exceptions are things that you are not expecting from the user, but they by mistake or by anything, on purpose or whatever, they do. And this is not the user's responsibility to not to do that. This is the programmer's responsibility to handle those exceptions. So what happens if I come and press an enter and go? Should my program crash, or should this what should I do? Should I show a message? How do I even detect that they, instead of an integer, they entered space, or they entered new line, or what, another character? What is the mechanism to do that? So this exception handling has not been implemented in any of these codes, and that has a good bonus, especially for A plus type of students, and that's version 4, which is optional. So if you do all the 3 parts, this is A minus. Everything fine, everything is good. This is A minus. If you want A plus, that will require uh, the implementation of exception handling. There's no clue for that, so that's a lot of work. Probably you need to use your skills. So from version 1 to 3, which will give you an A mark if you do everything correctly, everything is given. All the code is given. We're not talking about coding. This course is not about coding. That's why the code is given to you. You just need to be able to implement this, understand this, and meet the deadlines, communicate with other members. So feel how it's like to manage a team if you are a project manager of that team, or how to work with colleagues in a team as a member. Other modules, other parts. So we said these are the modules. The project manager will take care of module D and putting together all the modules at the end of the day and testing with this main. Like this is the main, a simple main to test all the programs, and you will test this. The project manager will collect all the projects at every stage and will test that. But when you come to the class, every programmer will explain their own program, and the project manager will just uh, this one is for the project manager to make sure everything is working. If a programmer has a problem, the project manager should know before coming to the class, and the whole group should support each other to solve that problem. I guess within this scope, we will not face that kind of problem because there's no coding involved. But if something like that happens, yeah, everybody should come together to solve the problem. I already showed this folder, so this is the video how to comment and the instructions on how to comment. Now we reach to the part that is absolutely important for this project. From version 2, for version 2, 3, and if you do the optional version 4, GitHub is being added. It means every single person will create a GitHub account, will install Git on their computer, will install TortoiseGit, and TortoiseGit is basically the tool you commit your code and you push your code to the GitHub, and you will add me. I will show you in basically in a minute my ID. You will add me as a collaborator to your Git account so that I can go there, check the code, manipulate it if I want. And you should make your Git account private for the end until the end of semester. After that, you can make it public. This having Git is, first of all, absolutely essential. Not for just this course. This is just the beginning. Later on, you will push your code to the GitHub, and if you're going for an interview, if uh, if they Google you and your Git comes up and they see codes that you have there, especially for those who want to do purely software, it's very important. Um, your Git that you start will play the role of your will give you credit. Your credit in the future will come from your Git. Um, if you're like like me, I'm not 100% software person. I'm hardware and software, and sometimes like I'm an embedded system developer. Still, that counts for me. But if somebody is like wants to do only software, Git is something that you really need to update. Push your code there. So do it now. This is the this will remain with you. Your Git account will remain with you later in other courses, in next semester courses, and in your career basically. You're developing a repository, multiple repositories in your GitHub account for different projects, and let's start it here. For that, is this clear so far? Please answer. Everybody answer this question. Is this clear? The Git part, is this Git part clear? The um you don't need Git for version 1, which is due next week, this time, next week class time. But for version 2, version 3, and version 4, if you do, uh, you should definitely push your code to the GitHub. We will check your GitHub, and you need to make it private and make me collaborator. How to do all these if you don't know? Thanks to Professor Fardad Soleimanlu. He's the head of OP, basically C++ programming courses, both OP244 and OP345. Um, he has very good tutorial on how to open a GitHub account, how to install Git on your computer, and how to install and use Tortoise Git. I will put the link for his tutorials. They're on YouTube, so I will put the link for you. You guys, you need to go and watch. If you already know, you're fine. If you already have an account, you're good to go. But if you don't know, please learn all the details from Fardad. He explains there very well. And next semester, by the way, you will do the same thing. If you take OP244, you will have to do the exact same thing. So you will not only benefit for now, you will benefit for your career by having Git, but also next semester at least you're doing workshop 0 beforehand, and that will be important. So without a Git, version 2 and version 3 will not be acceptable. You need to not only do the commenting and understand and all that we discussed, but also you need to push your code to Git. Every individual needs to do that, including the project manager. So project manager does his code plus this Excel sheet report, pushes to his own Git, and every other programmer in the group completes the code and commits it. You can commit multiple times. You can see on Git, and you should push your code to Git version 2 and version 3. Some tutorial is here, but let me see. What do we have? Git basic. It's Git basics. Well, you can read this. This is fine. But what will most likely be the most efficient way of learning how to start with Git is Fardad's video. So I will put the link on where you will see all these in the project document on Learn. On Learn, I will put all these. And final, okay, let me see. Any questions so far? Any questions? Mudit, what is the question?
Sir, my question is regarding the Git. Like, uh,
Hmm.
if, even the individual members have to commit their code on the
Yeah,
GitHub,
yeah, everybody.
and and how to like collaborate on that on Git, and how to. I'm just bit confused how to do that.
Everybody will be responsible for pushing their code to Git. Everybody. And if you come to me, if somebody comes to me for version 2 or version 3 or version 4, they don't have a Git, we will not even talk about the code. Everybody is responsible. The project manager will not only push the code module D, because we said module D should be implemented by the project manager. But since project manager is also completing this Excel form, probably we need to also I need to also show this. Project manager will push his or her code on Git plus this Excel sheet. But everybody is responsible for their own code. And now, is it clear now? You don't need to communicate about it. You just need to be supportive. Like every team members, if somebody doesn't know, couldn't understand how to push their file to Git, you just need to be supportive. But the responsibility goes to that person. And coming back to your question, uh, I have in the I have put in the tutorial that we will go over now. Uh, 65. You guys, if you have problem with this, let's discuss now and change. What I'm considering is 65% of the total mark is for individual activity, like Git. If somebody doesn't have Git, that person will lose 65%, not the whole group. But 35% is for the teamwork. So how do we know that teamwork was good? It is reflected uh, in your teams. I can see the communications, and if somebody is not working at all, if somebody didn't show up, other members, if 2 or 3 members ask somebody be kicked off that group, that can be done, um, provided that if that person is not really working, doesn't really care. So 65% is individual. If you do everything very well on your own, you will get the 65% of the mark. 35% is how you collaborate with each other and how you support each other. We don't want to just do, like, in real life, projects never are single person projects. They are all done in teams. So here is the place to learn how to support our team members. And if you, as a team, do a great teamwork, support each other, um, uh, do the deadlines, the project managers can get the files on time, project manager uh, can help others, like team members, programmers can help, everybody can help, you will get this 35% as well. But if I hear that everybody is complaining about everybody else's stuff, it will become an individual thing and you will lose the 35% of the mark. Everybody will lose this. This is individual. You either get it or not. But this 35 is teamwork. Either the whole team gets it or the whole team doesn't get it. Let me know your thoughts. Is this clear?
So what if
Mm-hmm.
I
Victor.
got a question.
Yeah.
On teamwork side, what if one of the group members didn't do their job? Like we try to contact them, and if they don't do their job,
That person can
or
be, yeah, that person can be kicked off. If there is
well,
one person, if there is
well,
what
yeah,
yeah, that person will be kicked off, and the other three, if the other three or the other two, doesn't really matter, can collaborate and can make a team, they will get that 35%.
But the work won't be like complete. I mean, because
Yeah,
we're relying on some sort of like group
yeah,
members to
that's why.
do their work,
Okay,
right?
very, very good question. Excellent question, Victor. The modules, you will see, the modules are not dependent on each other. It's not like a real
Oh,
it's not like a real project that every module depends on the
okay,
other one to work. These are independent, basically independent modules put together at the end of the day, and
okay.
each work individually, so we won't have that problem.
The other question is, how can we divide up the first week of the preparation of the project? We have to divide the work, right? Because you show us there's like 4 folders or
Hmm.
maybe 5, and then uh, how can we divide the work? Are we divided by ourselves or
You should,
like assign it by
yeah,
ourselves, or
you that's your task. You will,
that's our task?
that's your task. Yeah, that's the initiation part of the project. That's your task, and that's why we have created these groups, and you're in these groups. So start communicating in these groups. If you think you can be a good project manager, go ahead and pick that. You should come up with a project manager in your group anyways, within today or tomorrow, like in 2 days. You should know who will be the project manager. That person, the person that will become project manager, will do module D plus that Excel sheet, and then
So
the other three will do modules one, module A, B, or C, and it is again up to you. I don't know. You should decide who will do module A, who will do module B, who will do module C.
so is it Professor you will decide who which like each group will be decide one member should be to be the project manager
It's up to you. You should select a project manager. Like everybody should,
on our team?
yeah, on
Oh,
your
okay,
team discuss on your
okay.
team. If somebody is volunteer, and everybody else is okay with that person to become to be the project manager, then that person will be the project manager. Otherwise, anyways, you should come to a you should find a common ground for that, to who becomes a project manager.
One more question. It's the role, is it gonna be stick till the end of the project?
uh
Like the project manager will gonna stay with
yeah.
project manager till
uh
the end of the project.
uh that's a good point. If we could rotate, we can rotate that.
Okay, all right,
Yeah,
sounds good. Thank you very
yeah.
much.
I think we can rotate that. If you want to rotate after, so one person can be a project manager for version 1, and then you can rotate for version 2, 3, and 4, if you like. Otherwise, that person can remain the project manager until the end of this project. That I should add here. Yeah. I will add rotation of project manager. I will add this here. Thank you so much. Very good point, Victor. Okay, what else? Okay, so let's just,
Professor,
yeah, Simrat.
uh, like in this week we are supposed to do the version 1, right?
That's right.
Yeah. So I just want to ask that every member means the each member first, second, third, and fourth is supposed to do the module 1, 2, 3, 4, or means the like fundamental one and manipulating the
Hmm.
another one is supposed to do.
Yeah, everybody is responsible for their own module, because, as I said, these are not interdependent modules. They're almost independent modules that are just put together. So you need to know the details of your own module, not everybody's modules.
Okay, Professor. Thank you so much.
Yeah, sure. What else? Okay. Uh, so by now, we know all these uh, project versions. So this table shows you uh, what files are required, and what each task is, the grade that you will get. It gives you a little bit more detail of what those codes are for. Project dues, as I said, August 3rd, class time is the due for version 1. Uh, 20 minutes, each group will come to the class for 20 minutes, and they will present their work. By presentation, I mean not like a presentation, but they will show me what they have done. Um, and you will get the grade right there. And August 20, so then they will leave and the next group will come. So 20 minutes for each group. Uh, August 10 is for version 2. Again, this is Wednesday class time, and the last one is our last class, August 17, version 3 and 4. If you do version 4 also, you will also need to show me on August 17. Um, project details. We talked about Git thingy. My Git is this one. This is my Git ID. So you will learn how to add collaborator to your Git. Um, you watch Fardad's videos. He explains it very well there. This is my Git. Add me. My picture is there. My profile picture is clear. Just make sure it's me. And don't add any other person. Your Git account should be private. Nobody should be able to see your until the end of this course. Obviously, nobody should be able to see that your I mean not account, that the repository that you're keeping your files in. That repo should be private, not public, and only I should be added as the collaborator so that I can see that. After that, when we're done with this course, you can make public everything public and continue with Git in your career. Communication is through Git private groups you are already assigned in. If you are not assigned to any group, let me know. It's most probably because you didn't have enough activity or quiz submission. Evaluation, we know what, like each version gives you some mark. The first version gives you C++, the second one B++, the third one A minus, and the last one if you do A plus. And this is how it works. We discussed this: 65% individual and 35% total grade. If you see somebody is not working in the group, and if you, like, if it is 2 or 3 of you and you realize that that person is not responding, you can that person can be kicked off of the group. uh, Kicked off the group. Rotation, I will add. Collaboration, we will understand from the amount and from the quality of discussions you have in your teams. Appendix A is the functions that are used for each of these modules. Go and learn these if you don't know what these modules are doing. And these are the deliverables. Deliverables for function 1, sorry, for part 1, part 2, and part 3. You will post the deliverables at the end of each version in each group. So you will say, okay, now after presentation, you present it to me. Next week, you come to class, and I will post which group should come at what time, because you just come for 20 minutes to present your work. You come to class, you present to me, and you have time to upload all these deliverables to that group. I will check it in that group. I will check your submission and your grade will be finalized. For every stage, it's exactly known that what should be delivered. Plus, you will also upload your code to GitHub. I think by now everything should be clear. I will post all these by in like 2 to 3 hours, I guess, from now. Is there any question?
Professor, I have a doubt. Like,
Yep.
yes, yes, Professor. Uh, when we need to collaborate you on Git when we are presenting in class the our code, right?
You will when you come to the class to present your code, each person will present their code, and also the project manager will present the code that he or she has, module D, which is just less code, plus this file, this Excel sheet will show us this Excel sheet. What is this Excel sheet? This Excel sheet is actually the project manager's Excel sheet. And you need to, because now you have less load on the code, the project manager has less load on the code, but this task balances that. So what the project manager needs to do is project kickoff, what are the activities the group did, what is the time, when is the deadline for everybody, things like that. So it's kind of a report that the project manager needs to put in, and this is the for project kickoff version 1, version 2, version 3, and version 4. So the project manager's responsibility is module 4 plus this Excel sheet.
Got it, Professor. The code which we need to present needs to be on GitHub, right?
From not for the first version, but yeah, for version 2 and version 3, you need to also upload it to Git and show me your Git.
Okay. Got it.
Okay, great. And the final thing is this final report and test cases. If you look at another Excel sheet that we have here, hopefully it will open. Okay. Now, this is the Excel sheet to test your program, because we said you are responsible to implement your code in Visual Studio, right? We give you the code, you need to understand it, comment it, and run it. When you're running, you see now we have 3 modules for fundamentals. We have 3 modules for many version. These are each version 1, fundamental version 1, version 2, version 3. Let me see. No, sorry. These are for 3 different versions that you have, and to test the program, you will do each of these inputs. So in the main, basically, you will run the main and you will input these in the console. It is a console application. So in the console, based on what is given here, typical cases, like you will see, if you go through it, you will see what it means. The data that you input in the console, you should write it here. Everybody will complete it based on like it's not the responsibility of the project manager, it's the responsibility of every team member to complete their part. If like Mr. X is taking fundamentals, then that Mr. X is responsible to complete these 3 rows of this Excel sheet for version 1. Based on this input, what was their input, what is the expected result, and what they see in the output of the program in the console. This one will be the final test report of your program, and everybody will. This will be a shared Excel, I guess. You can share it in your group. One person can share in their group, and everybody can fill individually, but you will all have this one submission, one Excel submission. But every single person will be responsible for completing the corresponding part in this Excel.
And Professor, what is about these minimal edge case, typical edge case, and maximal
Yeah,
edge
go
case?
for that you need to I refer you to read this part. If you don't understand, we will test. So these are read this program test case. There is another Word file here. There's this program test case. All the test cases are explained here. Go ahead and read this document. If you didn't understand, we can discuss this later. But everything is well documented here. Okay, this will also be shared. What else? Any questions, any doubts?
Yes, sir. I got questions.
Yeah, Victor.
So for the workload that we have, what I understand is we for so we need to do the coding if it's if the member is not a project manager, and
Yeah,
and also we need to report inside the programming test case, right?
that's right.
Two
Exactly.
things.
Exactly.
And what about the GitHub? What kind of work are you expecting for us to upload into the GitHub? Is it only
Just
the PDF?
your code. So when you write your code, you will have two codes. You will have the header and the C file. You will upload your code to your GitHub.
Right.
Well, I guess you just upload the code. No, you don't need to upload any Excel sheet, any of these two Excel sheets we discussed now. One of them everybody should complete. This is the programming test cases. One of them was only for the program manager. So these Excel sheets you don't need to upload to your GitHub. Just upload your code, header code and C code to the GitHub. And the fact that you are able to commit and push your code to the GitHub is enough. So I will just check if your code is there or not.
Okay. Final questions. The Excel sheet, is it gonna be you're gonna be
Share.
evaluating
You can you can share it in Teams, and this will be
in the
evaluated
Microsoft team,
in the
right?
Microsoft team in your group.
Okay.
When you share it, everybody of that group, all the group members will
Yeah.
have access to it. You will complete it all together,
Right.
and then we will evaluate in Teams.
Okay. Thank you very much.
Yeah, thank you. I think everything is now clear. Well, if you don't have any more questions, I'll be busy modifying this and uploading. You will find your project today, and please start soon. There is no quiz or activity task except for activity 11, which is due this Sunday. Please do that. And everything else will be just this project. Thank you very much. If there is no question, have yourselves a one. Yeah, Victor,
So,
you have a
sir,
question?
one more.
Yeah, no problem.
For on the next week, is it the last week where we can do a ICT presentation?
Well, I guess ICT presentations because the ICT presentations based on the
Because the schedule saying that we
it was due
three
on
to week
week 12. Yeah, it
right.
was due by week 12, and nobody, like a few people just did presentation. So I guess we will not have any presentations anymore.
Can we do one, like, because I wanted to do one, because can we do one on next week? Is it possible to do that? Like, I
Uh,
just record it and then maybe I just send it
yeah,
to
yeah
you.
you prepare that. We'll try to do that. Hopefully, we'll see how it goes. We have 6 groups. If each group takes exactly 20 minutes and not more than that, we will have enough time to see your presentation. Of course, you're very welcome to do that. Prepare and send it to me, and we will see how it goes. Hopefully, because the deadline has passed, hopefully we will find some time to these presentations as well.
All right, thanks.
Thank you. What else? If not, have yourself a wonderful week and start this soon. Let me see one message here. Okay, I'll check it later. All right. Very good. I think we're good to go. Thanks again for being here today and good luck.
Thank you so much, Professor, for today's class.
Yeah, thank you. So some questions are coming up. How to interact with team member in the group, sir? Just send them a message. Thank you. Just send them a message. If multiple messages from multiple people go to a person and that person didn't respond, that person can be kicked off the group easily. Okay? All right. Thank you, everybody. We'll see you next week, next Wednesday.